Okay, AP Chemistry class. This is a problem set of multiple choice problems. There won't be multiple choice problems on the test. However, it doesn't mean they couldn't give you this exact same question or one that's very much like it as a free response problem. So I'm going to just go through these quickly. It'll just give you some concepts to practice on. Okay, so this is in Unit 2, by the way, which is molecular. They call it molecular bonding. We call it covalent bonding. Same thing. And ionic bonding. So molecular and ionic bonding or covalent and ionic bonding. That's Unit 2. All right, so you can just go through these. We'll go through these fairly quickly. So there you have a diagram of carbon is the black and chlorine is the light. And it tells you that this is solid carbon tetrachloride. Tetra means 4. And you use those numeric prefixes like that, like tetra. So mono, di, tri, tetra, penta, when you're dealing with covalent bonds. So solid carbon tetrachloride, CCl4, is represented by the diagram above. The attractions between the CCl4 molecules that hold the molecules together in solid state are best identified as what? Well, these are two nonmetals, so they're going to be covalent bonds. They're going to share electrons. Let's see what the multiple choices are. Polar covalent. Now, that's a possibility. Oftentimes, when you have two different elements, it would be polar. That means the electrons are pulled to one side. But tetrahedral, it's just like methane. It's the exact same shape as methane. It's Ch4. It's a symmetrical molecule. Usually you have polar molecules only if you have lone pairs. The lone pairs tend to push the atoms into kind of odd angles, and that makes the electrons not be distributed evenly. But there are no lone pairs here. This is what you would call an AX4E0, meaning the central molecule, is bonded to 4 different outer molecules, and there's no lone pairs. So this is going to be, like methane, a nonpolar molecule. So the answer is polar covalent, nonpolar covalent, intermolecular attractions resulting from temporary dipoles. Let me be sure we got the question right. The attraction between CCl4 molecules that hold the molecules together in solid state are best identified. Okay, so it is a non-polar covalent bond. However, that's not the intermolecular forces. The intermolecular attractions are resulting from temporary dipoles. Remember that non-polar molecules are held together only by London dispersion forces. That's temporary polarities that are caused because all of the electrons are over on one side of the molecule. D is intermolecular attractions resulting from permanent dipoles. No, it's not polar, so they are not permanent dipoles. Permanent dipoles would be something like water, where the positive and negative side is permanent. So the answer to this one is C. And there it is. Intermolecular attractions resulting from temporary dipoles. So nonpolar molecules only have temporary dipoles from the electrons moving over to one side of the atom. Okay, let's keep going. All right. Number 2 in Unit 2, and I'm just scrolling through some multiple choice questions here. Which of the following scientific claims about the bond in the molecular compound hydrofluoric acid, HF, is most likely to be true? Well, let's look at it. Hydrofluoric acid, it's 2 molecules. It's called a binary compound. Binary means 2. Fluorine is the most electronegative element on the periodic table. So it's going to definitely pull the electrons over towards it. It will definitely be a polar covalent molecule, very highly polar. So let's read the choices. There's a partial negative charge on the hydrogen. No, that would actually be the opposite. The hydrogen would have its electron pulled away from it towards fluorine, and so the hydrogen side of this molecule would be positive. The fluorine side would be negative. B, electrons are shared equally between hydrogen and fluorine. No, it's polar. Fluorine is going to pull the electrons towards it. C, the bond is extremely weak. No, it's not a weak bond. It's a covalent bond. It's a fairly strong bond. D, the bond is highly polar. Yes, that's true. The fluorine is the negative side, and there it is, D. So answer D. Fluorine is the most electronegative element. Okay, let's keep going. Okay, I actually giving you this on one of the assignments, so I'm going to skip over this one. This is a multi-part, a 4-part free response. So any free response problem, not any free response, but the ones that I give you on our assignment that we'll talk about are going to be free response. Okay, 2 pure elements react to form a compound. One element is an alkali metal, so that could be sodium, potassium, lithium, something along that line on the left-hand side of the periodic table. The other element is a halogen. So halogen is the second to last row on the periodic, or second to last column on the periodic table, and that would include fluorine, chlorine, bromine, and so forth. Which of the following is the most valid scientific claim that can be made about the compound? Well, first of all, if it's a metal and a halogen, which is a nonmetal, it's going to be ionic. So before we even look at the answers, it's an ionic bond. Metal, nonmetal. So it has the formula. Let's look at A. It has the formula XZ2. The charge on a halogen is a -1 charge. It wants to gain 1 electron to be like the nearest noble gas. The charge on an alkali metal is a +1 charge. It wants to lose 1 electron. It has only 1 valence electron, and it wants to lose that electron so it can be like the nearest noble gas, which is the noble gas before it. So it's going to be a +1 charge for the alkali metal, the unknown alkali metal X, and a -1 charge for the halogen. So they're going to match up XZ, 1 + 1 - 1. So A, it has a formula of XZ2. That's not correct. That means it would have 2 negative charges on the Z. Z would be a -2. The X would be +1. That wouldn't balance. So that's not correct. It does not dissolve in water. Well, we know, just pick an example. We know that sodium chloride dissolves very easily in water. So it may be true that not all of these would dissolve in water, but at least some do. We know sodium chloride does. It contains ionic bonds. True. That's the answer. It contains covalent bonds. False. So the answer on this one is C. And there we go. You see how it's darkening over the correct answer. I trust you see that, okay? All right. Next. Okay. The elements carbon and selenium have the same electronegativity value, 2.55. Which of the following claims about the compound that forms C and Se is most likely to be true? Well, if they have the same electronegativity, they're going to pull on the electrons the same, with the same amount of strength. So it should be nonpolar. So let's see what the answers are. Carbon to selenium bond is unstable. That's not true necessarily. No. Carbon to selenium bond is nonpolar covalent. That seems to be true if they have the same electronegativities. The compound has an empirical formula CSE. You don't know that. You can't tell anything about empirical formula from this information. It could be true, but we don't know that. And the molecule of the compound will have a partial negative charge on the carbon. It shouldn't. If they have the same electronegativity, the electrons are evenly distributed. So no, that would be a nonpolar molecule. That would be a polar molecule. Excuse me. D would be polar. So we think the answer is B. And let's try that. And yes, it is. The answer is B. Okay, we'll keep moving here. Okay, of the following compounds, which is the most ionic? All right, so you have to find a metal and a nonmetal. Silicon and chlorine are 2 nonmetals. Silicon is it's a metalloid, but it's on the right side of the periodic table over where the nonmetals are. So we're going to say that that's a covalent bond. Bromine and chlorine are both nonmetals, so that's going to be a covalent bond. Phosphorus and chlorine, same thing. They're both nonmetals. Chlorine and oxygen are both nonmetals. The only one of these 5 choices that are not both nonmetals, which one is a metal and one is a nonmetal, is CaCl2E. So that one would be the most ionic. So let's check the answer. And yes, that's the correct answer. Metal, nonmetal for ionic bonds. Okay, of the following single bonds, which is the least polar? All right, well, fluorine is the most electronegative element. So what you're going to look for are 2 elements that have similar electronegativities. Today I'm going to send you all of the reference sheets but I believe that I have a periodic table of electronegativities in the reference sheet section on the Google Classroom. So what you want to simply find is which of these pairs has a difference of electronegativities that's the lowest. So if it was two of the same atoms, there would be no electronegativity difference. For example, O2, oxygen, oxygen, they have the same electronegativity, so that's going to be not totally nonpolar. Well, none of these have the same atom, so you're asking which one would have the lowest difference. Well, fluorine and hydrogen would have a huge electronegativity difference. That one is 4 for fluorine and 2.1 for hydrogen, so that's a 1.9. That's almost an ionic bond, but not really. It's just highly polar covalent. Again, all of them, oxygen and hydrogen, we know that H2O forms a polar molecule, so it's not going to be that one. The two that have the closest electronegativities would be probably fluorine and oxygen. Again, you can look at your periodic table of electronegativities. Fluorine and oxygen both have very high electronegativities, but they're close to each other. Oxygen is 3.5 and fluorine is 4, so that's not a very big difference. Fluorine is more electronegative, but not by much. So I would guess that the answer for that one is C. But again, using your periodic table of electronegativities would be the way to answer this question. And there it is. Yes, C is the correct answer on this one. Next question. All right, so it gives you a table of elements and electronegativities. That would have been helpful on the last question. So on the basis of the information above, which of the following arranges the binary compounds in order of increasing bond polarity? Okay, this is it's not an easy question. And I'll tell you why. You have two different types. You have both polar and non-polar covalent bonds. All the bonds here are covalent, but one of them is non-polar. First of all, methane is CH4. If you draw the Lewis dot structure of that, you see that it's balanced, it's symmetrical, it has a carbon surrounded by 4 hydrogens evenly. That's an AX4E0, meaning the carbon bonds with 4 hydrogens, and there were no lone pairs. So that's non-polar, and it's also very small. So the only thing it has are very weak London dispersion forces. The only thing non-polar molecules have are London dispersion forces. Okay, what about SiCl4? Well, Si is in the same group or column as carbon, so it's going to form the same kind of bond. It's tetrahedral, so it's also going to be non-polar, and it's also going to have only London dispersion forces, the only kind of intermolecular forces that attract nonpolar molecules to other nonpolar molecules. So neither one of them are going to have an increasing bond polarity. However, SiCl4 will stick together with other SiCl4 better than CH4 sticks together with other CH4. And the reason is simply it has more electrons. When you're dealing with London dispersion forces, and all things being equal, the molecule with the most electrons has the strongest London dispersion forces, because the London dispersion forces are temporary polarities that are caused by all the electrons going over to one side of the molecule. That's the only thing that nonpolar molecules have. So SiCl4 has stronger intermolecular forces, but that's not really the question. But it is in a way that it can have an increased polarity when it's around other SiCl4. The one that's totally different is SF4, sulfur tetrafluoride. And the reason is sulfur is not in the same group. Sulfur is in the group with oxygen, so it has 6 valence electrons. And if you draw the Lewis dot structure, and that's something we're practicing today, if you watch the video of the notes, and you should watch that before you come do all this, you would see that it's going to end up with lone pair electrons. And lone pair electrons push all the other bond angles of the other atoms in the molecule. It pushes them into odd angles, non-symmetrical angles, so they're not even. And that does create polarity. So whenever you have lone pair electrons, you almost always, I can't say always, there's a couple of exceptions, but you almost always have you have polar molecules. Therefore, SF4 is going to have dipole-dipole bonds, which are much stronger than London dispersion forces. They're usually much stronger. So definitely SF4 has the greatest bond polarity. And since if we look at the answers down below, A is the only answer that has SF4 on the right-hand side, which would be the greatest bond polarity. That would have to be the answer. And I'll click on the answer slide, and there it is. Okay, so that's the answer. Okay, let's do one more in this set. Which of the following compounds contains both ionic and covalent bonds? All right, so nonmetals are covalent. So SO3, that's two nonmetals, that's covalent. CHOH, those are all nonmetals, that's covalent. MgF2, that's a metal, magnesium, and fluorine is a nonmetal, that's an ionic bond, only ionic bond. H2S, that's two nonmetals, that's going to be a covalent bond. Okay, the last one is a little bit tricky. We look at NH4. NH4 are nonmetals. They're covalently bonded. However, NH4 is a cation. It has a positive charge. It's formed in an acid-base reaction, and it has a positive charge to it. The neutral molecule would be NH3, which is ammonia. That has no charge to it. But NH4 has an extra proton, so it has a positive charge. Chlorine ionizes, becomes an anion, and has a negative charge. So here's the trick to this. Even though all those elements there are non-metals, they do form an ionic bond. The ammonium ion molecule, NH4, is a positive charge. The chlorine is a negative charge, so that's an ionic bond. So the bond between the nitrogen and the hydrogens is covalent, but the bond between the ammonium, NH4, and the chlorine, Cl, is ionic. It's a cation-anion bond. So that's a tricky one. That's not an obvious answer, but now you know that. You know to look for that. Okay, so that's the end of this set. I'm going to put up another set here in just a second.